Algebra 7.3 deals with elimination. Okay, it's a little different title in your book, but we're going to deal with elimination, and it's another method of how to solve linear systems of linear equations. The first thing we did was we did graphing, and then we did substitution. But substitution, as you probably figured out in the homework, had its limitations. Okay? So in this case, Algebra 1 7.3, we're dealing with another method called elimination. Elimination can work for any equation. So if there's anything to master, it should be elimination. So we're going to go through the steps. Negative x plus 2y minus 8. So what I'm going to do, what they want is to get the equation to have an opposite coefficient. Our goal, just like the title, is to eliminate a variable. In order to do that, they have to cancel each other out. In order to cancel each other out, we have to go ahead and, in order to cancel each other out, they have to have the opposite coefficient. For example, if I had negative 2 in front of an x, I have to get a positive 2. And I can manipulate, but I still have to keep things balanced. So remember, I can do anything to this equation. But whatever I do to one, I have to do to every term. Yes? And I also have to do it to the other side. So I can manipulate as long as I follow the rules and keep the equations balanced. So for example, I have negative x plus 2y equals negative 8. X plus 6y equals negative 18. Okay? These are already opposites. So what I'm going to do here is I'm going to add them. When I add them, see, add the equations to get rid of the coefficient, I end up with negative x plus, so negative 1 plus 1, these cancel out. It ends up with 0. So 2 plus 6, I'm left with 8y equals negative 8 minus plus negative 18, which would give me a negative 26. Is that right? Let me check. My brain is broken. Yes, 26. Okay, I'm going to divide this by 8 and divide this by 8. So, okay, let me bring this back again. So basically, once I've eliminated it, now I have an equation that's only in terms of what? Y. And just like last section, we found out that our goal is to get things in one variable term so that we can solve. That's what exactly we did. Last time we substituted, this time we're eliminating by canceling things out. So 8y equals negative 26. Now I'm just solving this problem like I solve any other problem. In order for me to get y by itself, I'm going to divide 8 to both sides. This cancels out. I end up with y equals negative 3.25. It's my first answer. Okay? Oh, that goes here. Y equals negative 3.25. I solve for a variable. The next thing I do, the last thing I do is I take this and I'm going to plug it into whatever equation. Let's do it this one because it seems easier. Negative 3.25. So this is replacing, oh no, sorry. This is replacing y, not x. So x plus 6 times negative 3.25 equals negative 18. So this is x plus 19.5 equals negative 18. Oh, sorry. Minus, because negative and a positive gives us a minus. And I'm going to add 19.5. I end up with x equals, yes, add 1.5. Okay? So, x equals, so my answer is x comma y, so it's 1.5 comma negative 3.25. So if you look at this answer real quick, you see how graphing something like this would be a little bit difficult because when you see where it overlaps, you can't get an exact number like you could do mathematically. Alright? So elimination, this one technically if I had to choose, I could use substitution. But elimination can be applied to everything. There's no rules. It's, it might be a little longer. Substitution might have been easier. But I could still use elimination for this. Now the next problem we're going to be using, you might need to use elimination only because substitution will only make it difficult. So go ahead and write this down, okay? And we're going to do one more problem. Okay, so in this one it says to solve 3x equals 6y plus 12, negative x plus 3y equals 6. Okay, this is all scattered. Okay, the equal signs don't match up. Before we do anything, let's rearrange the equation, and you can't just move it. You have to follow the rules. For example, what I mean is you see how the y here, so let's look at 3x equals negative 6y plus 12. Well, the y is on this side of the equal sign, and I want the equal signs to line up. In order for me to do this, okay, I have to move this. I can't just take negative 6 and put it. I can if I want to rearrange this, let's say, because this is on the same side of the equal sign. But if I want to bring it to the other side of the equal sign, I have to do the opposite. So I'm going to plus 6y plus 6y. So my new equation is going to look like 3x plus 6y equals 12. Okay, this is going to replace this. So now I'm going to have 3x plus 6y equals 12, negative x plus 3y equals 6. Okay, so I'm going to do elimination on this so that you can get more practice on. And what's happening here is I have no opposites. What I mean is if I added these together, unlike the other ones, they don't cancel out because they're not exact opposites. It's positive 3, this is negative 1. These are not exact opposites, and these, these don't matter. It's just either the x or the y that needs to be exact opposites. In this case, I can make them exact opposites. I just have to make sure to apply. So in fractions, if I multiply the top, I have to multiply the bottom. So this one, the rule is whatever I multiply one term, I have to multiply all the terms. Okay? For example, and I can multiply both equations by the same thing, or this equation by one number, this equation, it doesn't have to be the same number. Okay? For instance, I'm going to go ahead and multiply this whole thing, okay, by, I'm going to multiply this whole thing by 3. Because if I multiply 3 times negative x, negative x is going to give me negative 3x, which is the exact opposite of 3. Okay? So, I'm not going to do anything to the top part. I can, if I need to. For example, if there's not a number they both have in common, I can multiply both top and bottom. So, but in this case, I don't need to. I just can multiply the top. So I'm going to go ahead and just bring this over. And then I'm going to take this, and it's as if I'm distributing it to every term. So 3 times negative x gives me negative 3x. 3 times positive 3y gives me positive 9y. And 3 times negative 6 equals 18. Sorry, 3 times positive 6 equals 18. So I manipulated it, but I didn't change anything. The equation is still balanced. Now from here, though, I have the opposite. And what I can do with the opposite is I can add. And when I add 3x minus 3x, this cancels to give me 0. Okay? That means I don't need it. So then I do 6 plus 9, which gives me 15y. Okay? And then 12 plus 18, which gives me 30. Well, now I have how many variables left? I only have one, which is y. So then I can solve. 15y, divide both sides by 15, I end up with y equals 2. This cancels out. 30 divided by 15, y equals 2. So I have one answer. See how that works? And then my last step is to plug it in. Which equation? Doesn't matter. I'm going to choose the second one because it seems less complicated. So I'm going to plug it in to y. So negative x plus 3 times y, which is 2, equals 6. So it's the same equation as this, except y is in for 2. So how many variables do I have here? Just one. And now I can solve. So once I'm able to eliminate one, it's just, you're home free from there. It's just your previous algebra. So 3 times 2 is 6, so negative x plus 6 equals 6. I'm going to subtract 6 by both sides. I'm going to do negative x equals 6 minus 6 is 0. Divide by negative 1. I end up with x equals 0. Okay? So my answer, that means these two lines cross at 0, comma 2. Alright? So, go ahead and write this down for elimination. Try page 404, number 8, page 404, number 8, and I'll see you in class.